There's been a heist at the Royal Institution and a man-made diamond was stolen. That's the moment caught on the Royal Institution's own CCTV cameras. Tonight's audience, when you were queuing there, you were witnesses to a crime and the thief has escaped. This is the third and final of this year's Christmas lectures from the Royal Institution. And these lectures have explored the principles of forensic science. And through the course of this final lecture, we're going to try to identify and to bring to justice a living body, a dual thief. Here in the court of the Royal Institution, we will put on trial a suspect accused of stealing the precious man-made diamond. So the sole purpose of forensic evidence is to assist the jury in their decision-making in the courtroom. And at the end of this lecture, you will be the jury, and you will be deciding whether the suspect we have is guilty of the crime for which they have been accused. Now, as a forensic anthropologist, I often appear in court as an expert witness. And standing here in a witness box, as an expert witness like myself, we can offer opinions based solely on our professional judgment. And what do? We take it very seriously. We swear to tell the truth, the whole truth, and nothing but the truth. There are really important words in there. And some of the most influential figures in any courtroom are the lawyers. And tonight, our defense lawyer is he is one of the most respected and definitely one of the most feared advocates in Scotland. Would you please welcome Mr. Donald Finlay, KC. I would say I've had the pleasure, but it was not a pleasure, of being cross-examined by Mr. Finlay. But what I'm going to ask you to do, if I may, Mr. Finlay, is to talk to what is our future jury and what is their role and their responsibility, because this is one of the most important, serious things that you can do as a member of the public. In this country, if there is an allegation that a serious crime has been committed and someone is arrested and charged, they are entitled to have that case heard not by a judge, not by lawyers, but by a jury made up of members of the public. Tonight, you are our jury, and that's quite a responsibility. In order to prove guilt in any criminal case, the prosecution leads evidence and to try to establish guilt beyond a reasonable doubt. If you have a doubt, which is a kind of doubt you would have in your own lives about an important decision you were going to take, then you give the benefit of that doubt to the person accused. The prosecution has to prove its case on the evidence. It's not about personalities. It's not about which witnesses you like more than any other witnesses. It's about the evidence and the quality of the evidence that you find proved. And it's my job to make it difficult for the prosecution to try to prove its case. If at the end of it all you are left with a reasonable doubt, then you are bound by law and bound by the rules of this evening to acquit the person who is on trial. Thank you very much indeed. Mr. Finlay is going to join us and sit through the proceedings, and you will see him come forward at different times to talk to expert witnesses. I want you to remember that science isn't black and white. It is a variety of shades of grey. And scientists need to know how far they can go with the evidence. And when you're an expert witness, sometimes it feels like the expert witness is on trial as well. So it's a very uncomfortable place for science to be. But before we start anything, we need a suspect. And we're going to need some help in terms of identifying our suspect. Now, you'll have seen these sort of wanted posters before. And what we're going to want to do is we're going to want to fill in the silhouette, because who is this person? And we're going to start by doing it the old-fashioned way, perhaps the way you might have seen it done in films. If you can all look at the CCTV footage, which is of the burglary that occurred earlier this evening. And it's over so quickly, isn't it? So we're going to be joined by a psychologist from the University of Central Lancashire, whose team is working to establish the best procedures to extract the memories of faces from eyewitnesses. So would you please welcome Professor Charlie Froud. Charlie, what we're going to do is we're going to do it the old-fashioned way.
We are,
okay,
yes.
Not what we would necessarily do today. In fact, definitely not what we would do today. So,
yes, that's
I'll
right.
pass it over to
so
you.
We're going to try to build a picture of the thief. What we have is some features. We have some eyes, as you can see, some noses and some mouths. And what we're going to do is I'm going to ask you to tell me which picture you think is the best. So we have some eyes. So what I'd like you to do is I'd like you to call out if you think, as I point, you think it's the thief. What do we think about those?
Yes or no?
Or
yes?
very quiet.
No, oh no, it's not that one.
What about these?
Yes. Okay.
Perhaps a little bit better. And these eyes? Yes. Maybe about the same. And these eyes? Yes. Bottom set of eyes? No. No. So maybe it's between these two. So who thinks, we have to have another guess, who thinks these pair of eyes? Have one more. And these? Oh, it's
second
about
one.
the same.
I'm going to adjudicate.
You think it's the second one. So let's pick the second one then. So we've got some eyes for our photo fit. They can go in there. And let's look at some noses then. And we'll do the same thing. What about this first nose? No. This nose? No. This nose?
No. Oh, you don't like noses?
Maybe a yes in there with this nose?
Yes.
Oh, that's interesting. And this nose?
I think it's number 4.
Number 4, yes,
Yep.
I think so. There we go. So let's do the mouths then. Same again. This first mouth?
No.
No. This one?
No.
Or perhaps a little bit this one? A bit more perhaps for this one? This one? Ah, maybe and this one?
Oh.
So we're going to pick this mouth?
Yeah.
OK.
So this is who you think our suspect might be. If we imagine there were glasses all the way around, of course.
We have to, yes, we need to do that.
But what would we have done with that image in the past?
So in the past, the police would show this photo fit to other police officers and members of the public for them to recognise. And the truth is that the technique doesn't work very well. So now the field has been transformed in the last 20 years.
But you spoke to one of the witnesses tonight. Now, talk us through.
I'm interviewing our young witness here, and the witness is selecting faces from the screen. The best matches for the face, really in terms of the region around the eyes, because we know this is really quite important. And those choices were combined together, okay? And then what she did was she uses some sliding scales to enhance the age and the health of the person. And then at the end, she added on some hair and actually a hooded top, as she remembered what this man looked like. And the final image, I think, is up in front of us.
And how many faces can we remember, do you think?
Recent research suggests that we remember a lot, Sue. About 5,000 faces. So it's a really large memory we have.
So what we've got here is we've got an eyewitness working with you that feels that this is the best likeness. We have all these witnesses in here who've looked at the CCTV footage and they think it looks like this individual. What do we have in terms of any similarities?
I mean, the photo fit was made in a very simple way, wasn't it? We had 5 features that we picked, so there wasn't a lot of choice. So we wouldn't expect a great likeness. I mean, this is the latest system that the police have been using in this country and abroad to evolve the likeness of the face.
So where is our eyewitness who did that piece of work for us? Thank you very much indeed for all your hard work. Well, we've got good news. We've got good news because the EvoFit has done its job, and the police have received a call from somebody claiming that they know who the individual in the picture might be. So we have a suspect, Charlie, and maybe we're ready to start thinking about a trial, possibly?
Call Professor Charlie Froud.
Oh.
Professor, you say to the members of the jury that they individually might be able to recognise 5,000 faces?
This is what the research would suggest. Some people recognise less, some people more, but on average, for faces that we're familiar with, we can recognise about 5,000.
I'm very grateful to you, Professor. But what I am interested in, and the jury will want to bear in mind, is that in nearly half of the instances of an EvoFit, it produced no identification result of any kind. Isn't that right? Almost half.
That's true. So about 60% of the time, somebody is able to say a name for an EvoFit image. And so if we show that image to lots of people, it increases the chance of that face being recognised.
Given that nearly half won't recognise it, it also increases the chances of people not recognising it.
That's also true.
Thank you very much, Professor.
Professor Froud, you may step down.
Okay.
Charlie, thank you very much indeed. Thank you.
Thank you.
Let's carry on, because there's another way in which we can identify somebody, and that's the good old-fashioned lineup. So we're going to see whether you as an audience can identify. We're giving you another go at this. And to run this lineup, I'm helped by a psychologist from the University of Birmingham who studies facial recognition. So please welcome Professor Heather Flo. Thank you. Thank you. Thank you, Heather, for joining us. Can you talk us through what is a lineup? What does it mean?
Love to. So a lineup procedure is one in which the police have apprehended a suspect, and that suspect may or may not be guilty. So the police create a bit of a test for the witness, whereby they place the suspect in with a group of individuals who look similar in appearance to the suspect, but who are actually not guilty of the crime.
Okay, so let's welcome them in, please.
All right,
I don't know about you, but I think they're all guilty, quite frankly. But there we go.
Look a bit shady. All right, so drawing from your memories, we want you to help us out. Tell us which one of these individuals is the culprit, all right? So how many of you think number 1 is the culprit?
Ooh, okay. What about number 2? Yeah. Okay, 1 or 2.
Okay. And what about number 3?
Oh, again, just 1 or 2.
Okay.
Number 4, put your hand up. Okay, and if you think it's 5, put your hand up. Oh, I think 4 has just got it, would be my thinking on it.
I agree.
Number 4, could you step forward, please? Then I would say that our eyewitnesses have suggested that you may be the person who has committed a crime. And so we're going to call you back at a later date into the courtroom. Thank you very much indeed to all of our lineup. So Heather, that wasn't clear cut, was it at all? Where we didn't feel comfortable, there was a lot of consensus. What does that tell us?
It was really interesting. There's a difference of opinion. And one of the things that I did is I actually baited you into picking someone, and Mr. Finley would find a lot of fault with that, because I didn't tell you that the perpetrator might actually not be present, that it's okay not to identify anyone, right? Because it's really important not only to identify the guilty, but also to exonerate innocent suspects. The other thing is that all of the faces that you saw were facing forward. All you had the opportunity to see during the lineup test was the frontal part of the individual's faces, right? You also didn't see those faces move, so you didn't get all of these rich cues that might help you remember, such as other parts of the face.
So our lineup, we don't do that anymore, although it looks great in the movies as well, doesn't it? But you've been developing new techniques that will help us perhaps get that lineup into a better place scientifically.
Yeah,
and I know this
right.
is at a research stage,
It is.
but would you like to tell us a bit about it?
Yeah, I'd love to tell you. So for about the last 10 years, my colleagues and I have been developing a new lineup procedure So the witness who is looking at the faces in the interactive lineup procedure is able to grab those faces with their mouse and rotate the faces into any pose desired. And what we have found when we test this procedure against all of the other lineup procedures that are used around the world, and there are many different kinds, is that it allows witnesses to better be able to detect guilty from innocent suspects. And that's really important.
So we had two of our audience participate with you. They've not been in here when we did the lineup, so they don't know who we've chosen.
Excellent. There we go. Okay, great. What's your name?
Matthew.
Matthew, nice to meet you. I'm Heather.
Joe.
Joe, nice to meet you. Okay, so you're about to take a lineup test, and the perpetrator that committed the heist might not actually be present in this lineup, okay? So what I want you to do is to take a look at the individuals in the next lineup and see if you recognize any of them as the perpetrator. So go ahead and click next, okay? So what you can do is hold down the mouse button and then use your finger to rotate the individuals in the lineup, all right? So you could see them from different vantage points. You could see how the individual facial features are moving together. What we found in our experiments is if you allow witnesses to have control over the faces in the lineup, what they most often do is they rotate the faces to match the vantage point from which they studied the perpetrator. We control this in experiments where people either get to see the front of the face when the crime is committed or the side of the face when the crime is committed. And we find that people rotate the images to match that.
So are we ready to have a selection, do you think?
Yeah, let's do it. Are you all ready? Okay, so please enter in a number or write not present to indicate your identification decision. Fantastic. Which number did you choose?
Number 2.
Number 2. And how confident are you?
Around 60%.
60%, okay. What did you choose?
Number 4.
Number 4.
Around 10%.
Around 10% confidence. Yeah. Thank you very much. Let's give them a round of applause.
Really interesting, Heather.
Yeah.
Because we have a 2.
Yes.
We have a 4.
Yep. In this case, we have witnesses who had very low confidence. You know, I would say 10% is most definitely too low of confidence for that individual to be able to make an identification. And the one that's even at 60%, I don't think would really stand up in a court of law either.
And do we know ultimately which room selected?
So the room identified the suspect.
So we have identified a suspect, which is Ben.
Call Professor Heather Flo.
Professor, when it comes to asking someone to make an identification, what, if anything, do you do to test their ability to identify someone?
That's outside of the purview of an expert witness to do that. So no, we do not test the individual witnesses in a case.
And of course, some people may be no good at that. Do you think I would be able to identify someone?
I really don't know.
Well, there might be a problem, you see, because I have a thing called face blindness or prosopagnosia, that I don't recognize faces. This is true. So do you, from your considerable experience, accept that the ability of people to identify must vary, as in fact we've already seen, given that we have 3 people in one way or another identified?
Yes, and that's why we have to choose the most robust identification procedure, so that it'll boost everyone's ability to make accurate identifications.
Thank you very much.
Thank you.
Professor Flo, you may step down.
Both Charlie and Heather's research is revealing how to best help people successfully recall facial memories. But we all find it easier to recognize people that we know, members of our family, for example, but difficult if the individuals are strangers. But there are others who seem to be sort of superhuman and have superpowers, and they're called super recognizers. So I want you to welcome a retired police officer who established and ran the world's first super recognizer unit at New Scotland Yard, Detective Chief Inspector Mike Neville. A super recognizer. Tell me what that means and tell me about the unit that you set up.
Right, a super recogniser is a person with a fantastic natural memory. You're just born with this wonderful memory, you can remember lots of faces. And when I worked at Scotland Yard, I had responsibility for taking all the CCTV images in. And as I circulated them and said to officers, who are these criminals? There were certain officers who made lots and lots and lots of identifications, and we identified these people who got this superb skill.
Can you give us one of your success stories, if you wouldn't mind, please? Everybody likes a forensic story.
Well, the greatest success, I think, is the Novichok case, which you'll remember some Russian assassins came to Salisbury and they needed to find out who they were, where they'd come from. So two super recognisers were tasked to watch thousands of hours of footage of people entering this country from Russia. Then they were tasked to watch a week's footage of Salisbury, and they're asked, is anybody in set A, in set B? And that's how they found them. So it's good how the human mind is better than a computer.
And what percentage of the population have got this skill?
We think 1% to 2% have got some of the skills. They could be here right now.
So we're going to test where our super recognisers might be in the audience this evening. Thank you, Mike. Very much. Thank you. Right, now we've now got Steve and Rob, who are from Wi-Fi Wars, and you're going to run us through a game to see if we can spot any super recognisers in our audience.
That's exactly right, yeah.
It's over to you.
Thank you. All right, so yes, we are now going to test all of you and see how you get on at recognising some suspects. So I need you all to have your phones at the ready. You've already connected. And now I'm going to show you a face from 3 different angles. So take a look at the big screen and commit this to memory to the best of your ability. There's the first person from 3 angles. And now you have 10 seconds to tell me which of these 3 faces was that person, starting now. So A, B, or C. On your phone, choose A, B, or C, which one you think it was. You've got a few more seconds to do that. There's lots of nodding. You seem confident, but let's find out. Time is up. I can now tell you, yeah, all green at the moment. Let's see how that goes. First thing to tell you is the correct answer was B. Okay, 77%, so we can see a few reds around, but not too many. You can put your phones down for now. Commiserations to the red ones. We're going to go again with the second face, please, Rob. So a different face now, 3 angles again for those who remain. There's that face. From all 3 angles, 10 seconds. Was that person A, B, or C? But for those who remain, hopefully you've made your choice, because time is up. The correct, yeah, well done. The correct answer this time was A. And after that, 66% of you remain, so only 2/3 of you now, people who are still in, memorised these 6 faces. But now the lineup is going to be more difficult to choose from. No conferring which of these 3 was in that lineup of 6. Horribly cloudy night. A, B, or C, only one of them. So they all look the same to me from down here. So if you're still in, you're better than I am. And I hope you've done it quick, because the time is up. And the final one was B. How many are we left with? 6%. Wonderful. Right, those 6% of you, where are you? Where are my 6%? Yeah, good. And what we'll do now is we're going to go back through all of those rounds. Rob, you're going to select the person who was fastest at getting it right through all of them. And that is your ultimate super recogniser in the room. And a round of applause for that person who is Artemis. Where are you, Artemis? All the way at the back there. Well done to you. Very strong.
Is this something you're surprised by? Do you think you have those superpowers?
No.
Well, maybe we've just taught you something about yourself that you didn't know. Maybe there's a future career there for you, do you think?
Maybe.
Maybe. So when we pulled individual 4 out in the lineup, was it 4 that you had chosen?
Yeah.
I wonder if the room feels more confident in the selection of number 4, that our very own Royal Institution super recogniser also pulled out number 4. Well done, congratulations, well done. Thank you. Now you will know that the police use CCTV imagery like that, sourced by the super recogniser team all the time. And an average Londoner is captured 70 times a day on a CCTV camera. And this dense network of cameras means that we can use CCTV to track most movements of city dwellers. So have a look at this. This is a photograph, a train station. I wonder who that might be. Walking through the train station. There you are again, heading along the walkway. Gosh, I look really tired, don't I? That's what happens when you do rehearsals for the Royal Institution. Standing on the train platform, and I had no idea this was being done. Absolutely none. All I did was to say what times I was at different places within that journey to the rehearsals. So that CCTV footage is incredibly important. And to analyse that kind of footage, I want you to welcome a forensic image analyst and an academic who's provided expert witness testimony in courtrooms across the world. Please welcome Ray Evans. Ray, as a CCTV image analyst, will you talk us through the heist video and tell us what you see through your eyes?
Yes, indeed. So we can see it's not great footage. There's a lot of noise in there. The detail is lacking. I think it's important for me to say at this point that, unlike the experts that you've already seen, they specialise in recognition. Well, what we deal with is identification. All the work we do is geared to looking at the differences between sets of images. Okay? You could almost say the task is like a glorified spot the difference.
Now, we have a suspect chosen by everybody in the room here.
Okay.
And it's a man who's identified from the lineup that we saw earlier. And you have some images of that individual, and you're going to take us through a comparison.
Yes, I'll take it through very quickly. So we see the person come in, slow him down a little bit there.
So this is the suspect that we took out of the line. This is Ben.
Okay. Can we see any differences between those two people? The perpetrator is sucking his lips in. So let's move forward a little bit further.
So you can have differences, but as long as you have an explanation for that differences.
Precisely.
Okay.
Precisely. So we'll move that through there. So on this, I've highlighted the most glaring aspect, which is the ear. So we can have a look at that ear and we can say, well, what are the differences between these two sets of ears? Well, apart from the poor quality, I don't see too many things. We can see the outline of the helix there, which is the outside of the ear. It's quite rolled. We can see the lower part of the lobe. It's semi-attached there, so they would go into the similarity box. But remember, similarities does not mean that it is the same person.
Even though we've got CCTV footage, we've got a suspect within the first hour or so, it's the quality of the image that's the problem, isn't it?
That's right,
Yeah.
that's right.
Thank you, Ray.
Call Ray Evans.
Evans, despite some pretty heavy prompting from Professor Black, you can't be in any way confident that you are looking at the perpetrator, can you?
Well, I have a level of confidence.
Should the members of the jury understand that in the work you do, you can either exclude or include?
That's correct, yes.
And to exclude somebody is perhaps easier because there may be quite a distinctive facial difference, that sort of thing.
To exclude somebody, it is easier because you've got something that separates those two faces.
To include somebody, that is harder.
Yes, it is harder, but people can share similar features. And if those features are similar enough, it might be difficult to distinguish between one person and another.
So what the members of the jury have here is that there are some differences.
Correct.
There are also some areas where there appears to be a clear difference.
Relatively clear. I wouldn't say they're absolutely clear.
And in other areas there are some similarities.
Yes, yes, that's correct.
Just in a term or a phrase, describe your level of confidence in this case.
I would probably use the term limited support.
Limited
Maybe
support.
as much as moderate support, but certainly limited support.
Thank you very much.
Thank you.
Ray Evans, you may step down.
Thank you.
Thank you very much, Ray. Very much appreciated. Thank you. This is the bit you've been waiting for. I need a volunteer, please. Would you come forward, please? There we go. Thank you. And your name?
Carly.
Carly. So, Carly, I'm going to ask you to head off here with Isla. We're going to pop a little something on you. Nothing horrible, I do promise you. And what we're going to do is, for identification purposes, we're going to look at gait. Now, I don't mean that thing at the end of a fence that you open and close, because when we saw our suspect running away, that is their gait. The gait is the way that people carry their body or move their legs and their arms as they walk. Now, it's up to the court to decide what kind of evidence is admissible into the courtroom, and not all evidence gets into the courtroom. And by and large, judges are generally not scientifically trained. So we do have to make sure that the science that goes into them is robust. And it's important that the expert witnesses can inform the courtroom whether an evidence type is strong or weak, just as we heard from Ray Evans. That strength of conviction is important. Now, if you'd come and join over here, just step further back a little bit there, and we're going to, that's perfect. All I'm going to ask you to do, hand by your side, if you wouldn't mind, you can see that we've got some lights on your head and down the side here. We're going to turn the lights off in here, and the camera, if you watch, is going to track how you walk. So I'm going to ask you to walk just over to that cushion there, very slowly. Are you ready? Lights are going down. Off you go. And when you get there, I want you to stop. So you walk across. There you go. You can see the leg movement. You can see the arm movement. So that's gait. Now, if you stop, and if you walk backwards, I'll stop you, don't worry. Look what happens with backward. The leg moves. Bit of arm movement as well. Can I ask you to do something silly now? Yeah. Would you, on your left leg, stand and hop over to the other side? Oh, look, it's a completely different pattern, isn't it? Carly, thank you very much indeed. Well done. Well done. Thank you. Now, as you might expect, there's been a tremendous amount of research has gone into how our skeletons move, and it's really important in terms of high-performance sport, but also in medicine, so for orthopedic intervention. So we know a lot about gait, but when you don't know the person, identifying gait of that individual is really quite difficult. And sometimes there are some judges who are quite uncomfortable about allowing gait analysis into the courtroom. And all that tells us is that there's more research to do. Mr. Finlay, could I ask you whether gait analysis is something that has appeared in any of the cases where you've been involved, and whether it's an evidence type you'd be comfortable with?
I've never had to deal with gait analysis in any trial I've ever been involved in. We have expert evidence in a large number of areas, but it is important to have two things. Firstly, there must be an identifiable area of science. You know, you can't just take a hobby and call yourself an expert in it and you become an expert witness. So we need to understand what the science is. And then the person who is the expert must have devoted a good deal of time to study, to research, to the practical application.
Okay. If there isn't a lot of information supporting gait going into the courtroom, there's a tremendous amount of evidence in terms of DNA. And we've been able to retrieve some DNA samples from the glass cabinet. You know that when you're looking at the television programs, the minute they say the DNA evidence, everyone goes, the case is over. Because surely if there's DNA evidence, it must be absolutely spot on. We've got the right individual. But even DNA evidence isn't free from doubt. So to present the DNA evidence and how it's used in the court, please welcome the Professor of Genetics at the University of Leicester, Professor Turi King. Lovely to see you. So, Turi, we're talking about DNA, and DNA always been the thing that we think solves everything.
That's right.
But we want to talk about transfer, don't we?
do.
And persistence maybe, but transfer certainly.
Yeah.
So what do we mean by transfer? Can we show what we mean by DNA transfer?
Yes, and for that, we need 6 volunteers.
You do 2.
I'm going to do
Then
2.
we'll get to 2,
I would like
and we'll get to 2
in the
here.
burgundy to come down.
You gentlemen.
You come down. And you
up
would look in the cream
yes,
jumper.
that
Would
one.
you like to come
Then
down?
And over this side, let's take you and you.
Come on down. Bye. I'm going to stand here. Now, I'm going to send you 2 out where you're going to get looked after by our team. Right, now then, the rest of you, what I need you to do is I need you to wear some, sadly, I mean, it's especially from your outfit, non-Christmassy jumpers, I'm afraid. So you need to put those on. Can I welcome back our 2 lovely volunteers who are going to come in? Big welcome. amazing. And you are covered in DNA balls. Now, what I want you to do is I want the 6 of you to form a tight circle here, and I don't want the 2 of you to stand next to each other. So if you can form a circle facing in, and oop, that's right, perfect. Now I'm going to go over here. So what I want you to do is I want you to take your left hand, put it into the middle, and grab the hand of somebody not right next to you. Okay, now you're going to take your right hand, and you're going to do the same thing. Try not to grab the hand of somebody you've already got the hand of, if that makes sense. Great. Okay, now what I want you to do is I want you to untangle yourselves. You can pivot, you can step over arms if you want. So 3, 2, 1, go! Excellent. Keep holding hands, but try and untangle. Oh, it's tricky, isn't it? Oh, one in the middle. Now, because you can turn around and go backwards. Okay. I don't know, do we give up? I think maybe so. What we do is we get you in a line. So let's get you in a line. So when we started, we had, the 2 of you with the lovely hats on, had got DNA bubbles on you, but now, do you want to turn around? Oh my goodness, check that out. Okay, so what this is showing though, is that there is DNA transfer. So DNA has transferred from these 2 onto everybody else. So you've got blue going here, that's primary transfer, but then if I got this from this person, that's secondary transfer. Now that is happening all of the time. All you need to do is shake somebody's hand and then go and touch a door handle, and you've put somebody else's DNA onto the door handle. Thank you very much, everybody. That was fantastic. If you guys want to go out.
Call Professor King.
Tell me, Professor, if you will, please, DNA comes from various body fluids, skin cells, and so on.
Yes.
And when it is analysed, you can connect that to an individual to odds which are pretty well astronomical.
Yes.
You never say absolutely, but as near absolutely as we can.
Yes.
What can the presence of DNA on an object tell you, firstly, about how that DNA came to be on that object?
We cannot answer that question.
Or how long has it been on that object?
We can't answer that question either.
And for example, we've seen a video of a case. If I was to take my watch off and place it in the case and come back in 2 years' time, would it still have my DNA on the watch?
The DNA will have degraded, but it's possible.
Yeah. So we don't know when, we don't know how, we don't know for how long. And we know that it may be by direct contact, and we've seen that in your demonstration, but also by secondary transfer.
Yes.
Or tertiary transfer.
Yes.
And I can't remember the word for 4, but it could be 4 down the road.
It is. I mean, the amount of DNA that will be transferred will decrease each time, and it depends on a number of different factors.
How do you measure the amount of DNA?
A standard unit of measurement for DNA is known as a nanogram.
What's a nanogram?
So
what's in a nanogram?
It's a billionth of a gram.
So a tiny amount. Even the tiniest amount of DNA could involve somebody potentially in a crime.
Yes.
A tiniest amount of DNA could involve this young man. The light of innocence shining from his eye. Might it be important to know why somebody's DNA might be in a particular place, Professor?
Indeed. We simply present the evidence, but we cannot say how or when.
I suppose if somebody worked in a place like this, that might be very important.
Definitely.
Tell them where you work.
The Royal Institution of Great Britain.
Here! Your DNA's all over the place. Good lad. Thank you, Professor.
Professor King, you may step down.
An extra piece of evidence has come in. What we hadn't realised was there was a camera in the cabinet above where the ring was stolen. And you can see the camera in place there. You can see the hand come in and steal the ring. So we've seen identification from faces. Can we tell anything from hands? Now, we're quite used to the front of our hands with our fingerprints being identifiable, but this is the back of a hand. So we have a research team based both at the University of Lancaster and at the University of Dundee who are looking at identification from the back of the hand. So could you please welcome Ricky Boswell-Challands, please. So we had an image up here that showed in the robbery just the back of a hand. What is it that you can see and tell from the back of a hand?
Okay, so the back of the hand's really interesting because there are a number of features that show variation between individuals. So I'd like to invite you all to take a look at the back of your own hand.
There's always that phrase, isn't it? You know it like the back of your own hand.
Yeah, I forget mine all the time. So, if you take a look at the back of your hand, you'll see, and I'll look at mine, you'll see a number of features. We've all got creases in our knuckles. We've got various skin pigmentation, you have freckles,
birthmarks,
scars. So we've got a number of different features like that. We find more if we go under the skin. As we go under the skin, we've got a model to show here.
Well, that's a big hand.
Okay, so here we've got the internal structure of the hand. Obviously, we've got the skeleton. You can see the bones of the fingers. We've got tendons. We've got ligaments. We've got the musculature of the hand here, shown in red. They give the overall form and definition of the hand. And then we've got something really important. We've got the veins. And veins show a great deal of variability between individuals.
So if you were to look at the back of your right hand and your left hand, would you expect them to be different
I would
in the
expect
same individual?
very, very different.
Oh, okay.
We'd expect to see different patterns between identical twins even.
So is there anything about this vein pattern that's genetic? Because you've said that identical twins, it would be different. But if you were looking at a family, you know, mum, dad, brothers, sisters, is there anything in there?
We'd still expect differences. To the best of our knowledge, we do not think there is a genetic influence on the vein patterns.
And there's a database associated with the images that I know you're looking at. Have you been able to yet find the same pattern of superficial veins in any two individuals?
Never in two hands that we have studied.
And what's your database size?
We're currently nearing 5,000 individuals, two hands for most of those individuals. So within that 10,000, we've seen no duplication.
Brilliant. Thank you, Ricky. And I have to say it, but you have to give him a big hand.
Oh.
One of the reasons that DNA has been so successful in identification is because of the very large databases that we can interrogate. And to be able to interrogate large data sets of images, we can't do it individually. We need to involve a computer. So we'll start to use artificial intelligence to look at every image and say, can we extract the anatomical information out of those images? Now, several teams have already presented this work in the courtroom, so it has been deemed admissible evidence, and that's, I think, important to know. So what I'd like to do now is like to welcome in a computer expert, and he will talk us through what is happening in the next stage of research in this hand identification. So please welcome from Lancaster University, Dr. Brian Williams. Thank you, Brian. Thank you, Brian. So we've just been looking, we've got an image of the hand of the person involved in the crime. Mm-hmm. And of course, we have a hand of our suspect.
We do.
What would you do in terms of a comparison? What sort of information are we looking for, and how are we using computers to help with that?
So in terms of the hand images, what we're looking for is reliable anatomical information that we can find in both the suspect and the offender images. So what we do is we take thousands of examples of images that have already been marked up by experts such as Sue in order to show the vein patterns, the knuckle creases, some detail in the fingernails, and then we feed these into computer algorithms that we develop so that later on, when we come with case images like this, we can use the trained models to extract this data again.
So you have images of hands and you've trained the computer, I just need to get this right, you've trained a computer to say, find the veins and show me the pattern. And then you're able to compare the two patterns of suspect and offender. But how confident might you be that they could be the same individual?
Well, that depends on the level of information that we've got available. So one of the important things when we're developing a system for something like this is it should be a system that can evaluate itself. So it can evaluate how good is the quality in this image and how relevant is the information that we can extract. So in this case, we had excellent quality in the finger knuckles and in the dorsal side of the hand.
So are you quite content that you just might have the same individual?
I am confident in the extraction of the data.
Okay.
And in the evidence image, we have very clear images of the knuckle creases.
Okay.
So I am pretty confident.
And there we can see that again. So here is the image.
So what we see here is we see some very clear images, especially of the index finger, the major knuckle on the index finger, and the major knuckle of the middle finger. And we can see both of these clearly in this hand as well. We can also see the dorsal side of the hand, where we can extract visible vein patterns from that.
Thank you, Brian.
Call Dr. Brian Williams.
I didn't quite understand this. No doubt members of the jury do, but who carried out this exercise? You or a box of electronic gadgetry?
It was both of us.
Well, given the box of electronic gadgetry couldn't put the information into itself, who put the information into the box in the first place?
The evidence images were entered by me.
And the background software that you use is entered by?
The background software is developed by my team of computer scientists and mathematicians and anthropologists.
And to be fair, you are, of course, a doctor.
I am, yes.
Of medicine?
No.
Not of medicine?
I'm a doctor of mathematics.
Ah. Who is actually carrying this out, you or the machine?
It's a combination.
But it's a combination of a machine that can only run on the basis of the information that's put into by somebody who is not a doctor of medicine. I'm afraid, Doctor, I'm going to have to suggest that you are not an expert in this area. And for your information, I will be inviting this jury to reject your evidence totally.
Dr. Williams, you may step down.
Thank you, Brian.
Call Professor Sue Black.
Oh, my. OK.
Tell me. So in this case, you are looking to make, I assume, and the jury would hope, a fair comparison between two parts of somebody's body.
Yes.
Well, how many areas did you compare between the suspect's hand and the other hand that was taken from the video of the robbery?
So I compared initially knuckle crease patterns, and I also looked for vein patterns, but I was not able to identify veins because veins are not always visible in all individuals. So there was one basis.
One.
Knuckle crease patterns across all fingers.
One characteristic.
Across all fingers.
One characteristic.
Across all fingers.
I think we have that, don't you? And of course, there has to be a reasonable representation. The two hands, they were clearly in the same position?
No, they were not.
No, they were not. They were quite distinctive in their positioning.
They were.
So that would have to be taken into account, wouldn't it?
Absolutely.
So we have the poor quality of imaging.
Yep.
We have the fact that you did a very, very limited comparison.
I did what was possible on the comparison.
On creases in the fingers.
Across all fingers.
And in hands that were not in the same position.
Correct.
Have I got all of that?
Some of it, yes.
Yeah. It's been a pleasure as always.
As always. Thank you.
Thank you very much.
Professor Black, you may step down.
I had no idea where that was going, and that's really important. The courtroom is an alien place for a scientist. We don't know what somebody's going to ask us. We may have the burning thing that we want to say, but if the advocates don't ask us the question we want, we're not able to say it. The courtroom is really where science and evidence can be tested. Now, what the Crown will say to you, I'm putting the Crown's words into my mouth, as it were. The Crown will tell you that a crime was committed this evening, that the crime was seen on CCTV footage, that some eyewitnesses identified a suspect, that suspect has since, their hand has been compared and the gait perhaps has been looked at, the DNA analysis has been done, and we've looked at similarities and differences across the faces. The Crown's case would be that there is sufficient evidence to find this man guilty of stealing the diamond ring from the Royal Institution, a crime that you witnessed this evening. But that would be the premise of the Crown's case. Mr. Finlay, the defence case.
It has been my privilege to represent this young man. Decent lad, decent home, loving son. Spends his time in this building, earning a modest living to look after his old grey-haired mother. And yet the prosecution say he is guilty of the crime of robbery. On what basis? The evidence, and that's what you have to consider. We start off with a little exercise where we do an evil fit. And we discover that, yes, there's a close vote between two persons who may be the suspect. But from the very start, there is a close vote between two. How many others could we bring into this court who would fit into one or other categories? Then we have new technology, new science that is being developed. And what does that show? That produces a third potential suspect for this robbery. So we now have three. How many more do the Crown want, and how many more do the Crown want you to ignore? This young man, to feed his family, works in this very building. And in this very building, his DNA will be in every single corner of the building. The fact that it is connected with the robbery is irrelevant. It is neither here nor there. And you now know, when you get home tonight, you will be contaminated with the DNA of people you didn't even know existed before you came here. And Ray Evans, who a balanced and fair way, despite being pushed and prodded by the prosecution time and time again, relentlessly, remorselessly driving him in their direction, would not budge, and said, really, he couldn't say very much other than was a limited support. Where is this Crown case? There is no Crown case until, of course, the prosecution advocate joins in herself to try and provide evidence and talks about a hand where there are creases on one hand. And that is it. A hand that's not in the same position as a comparison hand, an image which is so poor that you have seen the consequences in this court of trying to identify somebody from such poor quality produce. Members of the jury, if there was to be a crime committed, it would be here tonight in convicting this young man of the charge of robbery. Without hesitation, I ask you to reject the Crown case, and at this time of year, to allow him to walk out into Christmas, to return home to his mother and share a modest, very small chicken sandwich for Christmas dinner, because it's the best he can do. I invite you to acquit. Hold me dry, boy. Hold me dry. Thank you very much.
Never knowingly overacted, Mr. Finlay, never. Okay, the moment has arrived where you now have to make a decision, and in all seriousness, I know we've had a bit of fun with this, but in all seriousness, you've had some evidence. You have to make a decision. I don't think there is a more difficult decision than anybody could make when they are a member of the jury. Is there sufficient evidence to find Ben guilty? Mr. Finlay does not need to prove innocence. He just needs reasonable doubt. I'm going to ask you, first of all, whether you find Ben guilty of the theft of a diamond ring from the Royal Institution. Is Ben guilty of that crime? Please raise your hand. Please raise your hand if you believe that there is reasonable doubt. Isn't that interesting? Do you know, there's one of the problems we have in a courtroom, which is if you have an even number of jurors, then you can have a split decision. How many jurors do we have in a Scottish court, Mr. Finlay?
15.
15. Why do we do that in Scotland? Because we can have a balance of probability that says one side is going to have a higher number than the other. You're not in Scotland, but if you were, there's a third verdict, and that third verdict is not proven. So we might be in London, we might be in the Royal Institution, but I would suggest that perhaps Scotland's not proven verdict is what you've come forward with this evening. Because based on the evidence that you've heard, I'm not happy that he could be convicted, given, I'm not finished yet, given the level of doubt that is in the room. And I think we'd have to be much more confident than that. I'm going to let him go because I think that would be the right thing to do. Did you do it? No, of course you didn't. Of course you didn't do it. Ladies and gentlemen, you have made an incredibly difficult decision. You have taken what is some science that you know you see on television, and television says to you it's never wrong. Well, sometimes we have to ask questions, the really difficult questions. And some of my best research has come out of the really difficult questions that a defense advocate will ask. Because if we don't know the answer to it, then we need to go find out. So science never stands still, it moves forward. It is at the core of the most important element of our civilized society. It is about justice. It is about finding truth. And you have done an exceptional job on that. Mr. Finlay, I thank you very much indeed for this evening. And may we never, ever end up in court again. Thank you very much indeed. Thank you. Institution Christmas lecture. And of course, right at the core of everything we had was a diamond ring. Diamonds, of course, being a girl's best friend. And we've retrieved the diamond ring. Don't ask us how, but we have. But it would not be a Royal Institution Christmas lecture if it didn't go out with a bang. 3, 2, 1.
Details of organisations offering information and support are available at bbc.co.uk/actionline.